Here we go. So my first question is before you, and it says that the mean amount of time it takes a kidney stone. Well, here, let me refresh my screen. There we go. The mean amount of time it takes a kidney stone to pass is 14 days. I have a friend that has terrible kidney stones, and anyway, she's got another one. She just passed one. She's got another one. And the standard deviation is 6 days. They're pretty painful and very difficult to deal with. I've heard. Suppose that one individual is randomly chosen. Let x equals the time to pass the kidney stone. Round all answers to 4 decimal places where possible. Okay. So what is going on here? Well, what we're talking about in this chapter is normal distribution. What is normal distribution? I'll draw it for you. It's basically bell curved distribution. That's a normal distribution or bell curve distribution. Same thing. It goes by either name. And what it is, it's how things are normally distributed, like the name says. It's what typically happens. So with what math and science people have found over a lot of years, hundreds of years, is they found that things spread out in a bell-shaped graph often, usually, normally. So in other words, like pick anything you want. If you want to talk about average height for females, there, I don't know what the average height of a female is, but maybe it's 5 foot 5 inches. I'm just guessing. And then there's taller women and there's shorter women, right? And most people are right in the middle. That's why it's high in the middle, because most people are average. And then as you go higher, taller and taller, women that are 6 foot or 6 foot 1 inch or 6 foot 2, there's not as many of those. So the graph goes down. There's not as many people super tall. And then as you go really, really short, like 4.5 feet tall, or I don't know if that's even, anyway, whatever, there's less of those. So most people are average. They're in the middle. And fewer people are super tall and fewer people are super short. Now that's not just for height, that could be anything. So if we picked average men's shoe size, I don't know what the average men's, maybe it's a 9, right? And then some men have bigger feet, 10, 11, 12, and some have smaller feet, 8, 7, 6, whatever. Most men's shoe sizes would be average. They're in the middle. And some men have really big feet, but that goes down. Not as many men have really big or really small feet. So that's what it means by normally distributed. Most things are average. If we measured IQ, there's an average IQ. Most people are close to the average. I think it's 100. The average IQ. And then some people have really high IQs. Some people have lower IQs, but there's less of those. Most are in the middle. They're average. And same thing for this kidney stone or anything else measured biologically. They're saying the average time to pass, for people that have kidney stones, on average, it takes 14 days to pass the kidney stone. But some people, it takes longer, 15, 16, 17, 18 days. Some people, it goes really quick. But most people are around the middle. So that's the point of a bell curve or a normal distribution. It's that most whatevers are around the average. It doesn't have to be people things. I could measure spiders. I think we've talked about it before. I could go out to the forest floor. Remember, we had some problems like that a while ago. Go out to the forest and grab 100 spiders, and there would be some average spider, width. What's the average width of a spider? Maybe it's in a certain forest. Maybe it's 5 inches, or maybe it's 4 inches. That's a little big, but 4 inches. Right? But then there's bigger spiders out there, 5, 6, 7 inches, but there's not as many of those. And there's smaller spiders, 3, 2, 1 inches, but there's not as many of those. The average spider, there's more of the average. So that's what I'm saying. This could be anything. It could be the weight of leaves on trees, and there could be an average weight, and most of the leaves would be average, and there'd be some really big leaves and some really small, but not as many. The curve would go down. So that's what a normal distribution means. It means really big in the middle, like a bell. It's like a bell shape. It's really big in the middle, and it goes down to the right and the left because most whatevers are average. So it's like a big bell like that because whatever's in the middle, that's where most whatevers are, whatever you want to measure. And so that's going to be highest in the middle. And then as you go to the right or the left, you get bigger or smaller numbers. It's less. So here's 14 days is going to be right in the middle. If that's the average, always put the average right in the middle. If the mean means average, the average amount of time, the mean amount of time that it takes a kidney stone to pass is 14 days. Now, the standard deviation is 6 days. That means how far things deviate from the middle, right? Because not everybody's average. Not everybody who has kidney stones does the exact average all the time, of course, right? Some people go longer, some go shorter. Well, how far are they off the middle? That's what standard deviation means. I don't know if you remember that when we studied it earlier. It's how far off the middle. Well, typically by 6 days. So they're up to 20 or subtract 6, that'd be what, 8? So I went 6 down that way and I went 6 up that way from 14. So anyway, you don't need to do that. You don't need to write that down. The calculator is going to handle it all for us. But I just want to give you kind of a general feel for what it is as we dive in. So normal distribution is bell curve. It's big in the middle, highest in the middle, and it goes down to the right and the left. It spreads out. So let's go back to the 14. You don't really need to do anything with the 6. I'm just going to put the 14 in the middle again of the bell curve. So there's the 14 because that's the average amount of days it takes for a person to pass a kidney stone. But some take longer. Some take 15 days, 16 days. Some take shorter, 13 days, 12 days, etc. All right, so let's go on with the question. Enough with the intro. Let's go to the questions. They're saying down here, what is the distribution of X? X is what? The time to pass the kidney stone. So we're letting capital X be the time to pass the kidney stone. And how is X distributed? Well, they said right here that it's, didn't they say? The mean amount of time, which is 6 days. Suppose, well, they actually never said. Well, anyway, we just know the whole chapter is normal. They should have said the amount of time is normally distributed, but they didn't. Anyway, so see this in they're putting there? That in stands for normally distributed. Let me write it over here. Normally distributed. That's what that in stands for. It's telling us normal distribution. Now, what are these two things? What they want right here is they want us to put the mean, and on this blank, they want us to put the standard deviation. So what is the mean? 14 days. What is the standard deviation? 6 days. So that's all they want in the first blank. They just want you to recognize that the mean is 14, the average is 14, the middle of the bell curve is 14, and the standard deviation is 6. So that's the first thing they want you to do, is that we're just recognizing that the number of days it takes the person to pass the kidney stone is going to be in normally distributed, spread out like a bell curve, whose middle is 14 and whose standard distance from the middle, the average distance from the middle is 6. Standard deviation 6. Okay, so there, it's all we need to do there. Let's go on to the next question, part B. So part B says, find the probability that a randomly selected person with a kidney stone will take longer than 11 days to pass it. Longer than 11 days to pass it. Okay, how do we do that? Well, let's go to the notes. Let me go over here to our notes. Find those with you really quick. Our exam 2 notes should have all the information we need. There we go. So I'm looking at the exam 2 notes, and coming on down, there it is, number 6. See how it says normally distributed? Let me take a picture of that. I'll move it back over to the program I can write on and put it here for you. Okay, and make it a little bigger for us. There it is. Okay, so there's the notes. Normally distributed. So if you look at the exam 2 notes, it's got it there for you. Normally distributed, mean and standard deviation given. Yeah, that's exactly us, right? We're talking about normally distributed, and they've given us a mean and a standard deviation. Okay, so what do? First, draw a normal bell-shaped curve and put the line in the middle with the mean below it. That's what I did, right? I drew this bell curve right here. In fact, I could probably draw a little better one when I got more room. Let me come on down and draw a better one. So come on down here and draw a bell curve like that and put right in the middle the 14, because that's the mean, right? The mean or the average is 14. So that goes right in the middle. Okay. So first do that. And put the line in the middle of the middle. Next, put on the graph to the right or the left of the middle, at the bottom, the value they mention. The value they mention. Put it on the graph. Next, put on the graph to the right or the left, at the bottom. See that at the bottom? The value they mention. Oh, okay. What value did they mention? Do you see the other number they gave me in this problem? Right there, 11. So where is that 11 going to go? 11 is smaller, right? So it's going to be like over here. And in fact, go all the way up to the curve like that. Is that good? If they'd given me a number bigger than 14, say like 18 or something, I would have gone to the right. Is that making sense? So that line at the bottom is just like a number line. You just, 14's in the middle and bigger numbers are to the right and smaller numbers are to the left. So I put the 11 because that's the number they mentioned, okay? And then we come on down to figure, and what did they say? They said longer than 11. Longer. So where are the numbers that are longer than 11? Do you realize that it's going to be all the numbers this way? Is that making sense? Because, right, if you look at this is 15, 16, this is 13, 12, 17, 18, 19, etc. So go this way for longer than 11. You agree with me? See how it's to the right? If they had said shorter than 11, I would have shaded the other way. I would have shaded this way. That would have been shorter than 11. Do you see that difference? So if they say longer, you go to the right. They say shorter, you go to the left. Are we good there? All right. So now we've got the picture. Now we're going to use our calculator to get the actual answer. How do we do it? Let's come on down to the instructions here. It says, now, when they ask for a percentage, are they asking for a percentage? See, it says ask, give you a percentage. Which one are they doing here? Are they asking me for a percentage? They're saying find the probability. Yeah, that's asking for a percentage, isn't it? Because a probability is something like, like if I said, what's the probability of rain today? Well, not very good, maybe 10% chance of rain, right? That's a percentage. So when they say find the probability, they are asking for a percent, aren't they? When they say find the probability, indeed, they are asking for a percent. So I go, oh, okay, yeah. And they are asking, and it says, and n equals 1. Now, what does that mean, n equals 1? Well, we're talking about one person. See how it says a randomly selected person? So that's just one person. On Thursday, we're going to start doing these same problems, but we're going to have like 10 people or 20 people. So you don't have, all the problems today are going to be n equals 1. All the problems in chapter 6, it's just going to be one person at a time. Once we get that down, chapter 7 will start being more than one person at a time. So for right now, it's just one person. So I say, find the probability that a randomly selected person, n equals 1 person. Okay, come on back down. So they're asking for a percentage. It's 1 person. There's what we do on our calculator. Normal CDF, left, right, mean, standard. So let's go back up. I'll write that down, and we'll go to our calculators and do it. So it's going to be normal CDF. It's going to be left, comma, right, comma, mean, comma, standard deviation. Now, what do they mean by left and right and all that stuff? What they mean the left edge of the shading or the highlighted region, which is 11. See, it's right there. This is the left. Can you see that down here? Let me move this up a little bit. Make that a little better for you guys to see. So here, let me just write it above. Right here. This is the, well, no, I like it down below. This right here is the left. That's what we mean by left. That's the left edge. It's 11. And what's the right edge of the shading? Well, the right edge seems to go forever to the right, doesn't it? Doesn't it just seem to go and go and go forever? And these curves do, these bell curves, they never quite touch the ground. They're like an infinite bell curve. It goes forever to the right and the left. It never touches down. So what you do when it goes forever, watch this, guys, you're going to want to see this. You just put in like a bunch of 9s, like maybe seven or 8 9s. That's just like a giant number, 9, 9, 9, 9, 9, 9, 9, 9, 9, just a bunch of 9s, 7, 8, 9s, whatever. Just make it a giant, you're basically saying infinity. That's what you're basically saying. You're basically saying right forever. You're saying the shading goes right forever. So that's what's going to be the right number is, bunch of 9s. And then what's the mean? Well, we already know the mean. The mean is 14. The standard deviation is 6. So that's what you put into your calculator. So go find the normal CDF and do exactly that. So so you guys know where to find the normal CDF, I'm assuming, but let me write it out for you just to make sure we're all on the same page. So you've got to hit second and hit the vars button. Because when you hit second, you'll get the second function of the vars button, what's right above it. And what's right above it is the words distribution. So hit second distribution or vars, and then you'll get the different curves. Choose normal CDF, hit enter. And then once you're on normal CDF, just type in normal, the normal CDF, put in the numbers 11. Let me just go back, change the color here. 11, comma, and then there's the bunch of 9s, however many, comma, the mean was 14, standard 6. Type that in, hit enter. So that's what we do. And we get our answer. I'm going to do it too. You can put in as many, you can put in 29s if you want. It's just a giant number. So I'm getting the answer. I'll write it up here. 0.6914. We're supposed to round to 4 decimal places. 6914. 0.6914, meaning there's a 69% chance, right? Remember what the question was. Find the probability if you grab somebody random that their kidney stone will take longer than 11 days. Well, there's a 69.14% chance. So pretty likely, right? Almost a 70% chance that their kidney stone will take longer than 11 days to pass. That makes sense because the average is 14. So we'd expect that most people will take longer than 11. So we'd expect an answer higher than 50%. It's about 70%. That seems reasonable. Questions I can answer. We got to do part C still. And I'm going to show, let me show you on the calculator in case you're having any trouble. I'll show it on the calculator. Yeah, oh yeah, the newer TI. Yeah, good question. Yeah, let me show it on my calculator, which is the newer kind. The one that's on my laptop instead of my handheld is a newer kind. So that'll take care of that. Let's see. Go there. Go to my TI-84. There it is. All right, so you're seeing my TI-84, right, on my screen. So I'm going to go there. I'm going to go second vars. Let me show you here over here. Here's the buttons I'm pushing. Second vars so far. And here's the menu. I'm going to go down to Normalcdf. Hit enter. Yeah, so here's the newer kind. So I have the older kind. My handheld's the older kind. Here's the newer kind. It asks lower, upper, mu, sigma, and then you do it. Yeah, what the lower, I'm just going to click, so the lower, so that's like left, right. That's the same thing as left, lower and upper is left, right. This is, the mu is standard, is mean, and that's called a sigma, is standard deviation. So lower would be 11. Go down. Upper is where I just do a whole bunch of nines. Just do crazy. Just a bunch of nines like that. Down. The mean was what, 14? And the standard deviation was 6. And then just start hitting enter. Enter, 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 enter. There it is. 0.6914, like I told you from my handheld calculator. Is that good? I'll write that down now. You saw me do it.
So what if our number's higher than the
do somebody higher than what?
Than the, like mine was 17 days and my mean was 15 days.
And did it say longer than 17 days?
I don't have it.
Yes.
Longer? Yeah, good question. So I would come down here, normal. So the longer than 17 days, that would be 17 for your
Okay.
9 forever. You said your mean was 15?
Yes.
And what was your standard?
It was 4.
4. Yeah, you just said that you started 17 and go up.
Okay. Okay, thank you.
Yeah, good question. So there'd be your answer on that. Yeah, let me go back to my iPad. And let me show you again from there. Okay, so yeah, so let me write out how it looks for those that have the newer kind. So for the newer kind, it, what is it? It's, when you go to Normalcdf, it asks for lower, upper, and, whoops, no, that's for mu and sigma. Yeah, so the lower would be 11, the upper would be 9, a bunch of 9s, and this is the 14 and the 6. Yeah, so remember the lower or the left, the lower means the left edge of the shading. So it's all about the shading. This is what I want you to, this is what will really help you to just fly through all these problems once you get this concept. It's all about that yellow highlighted shaded region. So the lower and the upper mean the left edge of the shading. That's what they mean. And the upper means the right edge of the shading. And the right actually goes forever, doesn't it? The shading goes forever to the right. So that's why it's just, you know, basically infinity. 9, 9, 9, 9, 9, 9, 9, 9, 9, forever. Does that make sense? And then this next one is the mean. and the bottom one is the standard deviation. So
Mr.
it's all about the chunk of shading. Left edge, right edge of the chunk of shading on that. Is that making sense?
Mr. Herring,
Yeah.
I don't know. I understand how you're doing it, but I don't know how I'm supposed to do it for mine.
Yeah. So let me add one. Okay. So let me draw. So one thing, let me really encourage you guys, draw the curve. In the past, when I've taught this class several times, students are resistant to drawing the curve. Because I know they're just like, I just want to get it done. I know my own son, when I'm helping him with his math classes, he just wants to get it done, get it done, get it done. And I'm always telling him, well, you're going to get it done right if you take this step. So let me encourage you, don't skip this step. It'll really help you draw the curve, put the middle on there. Okay, so go ahead. So tell me about yours. What was the mean on yours?
16.
16. So draw the curve and put that in the middle. Don't skip that. I don't know if you're skipping or not, but I'm just saying in general, I found that students want to skip the drawing. Don't skip it. It'll help you because we're going to do harder and harder things. The drawing will really help you. Anyway, so what was your standard?
5.
5. And then what did it say for the phrase, like longer than or something?
Longer than 20 days.
Longer than 20. Okay. So where is 20? Is 20 to the right of 16 or to the left of 16?
To the right.
Yeah. So 20 would be somewhere over here. It doesn't matter. Put it wherever you want. As long as it's to the right. Put it 20. And then let that go all the way up to the curve. 20. Now longer than 20. Am I going to shade? To the right or to the left?
To the right.
To the right, exactly. Yeah, because longer numbers are this way, aren't they? Longer numbers, like 21, 22, etc. So there it is. So here's the shading right here, isn't it? So then the main thing to identify is what is the left edge of the shading and what is the right edge of the shading, because that's what this is all about. It'll be this way for the rest of the course. We'll have a ton of these kind of questions, and it'll always be what's the left edge of the shading and what's the right edge of the shading, So here's the left edge, 20. The right edge is infinity, basically, right? The shading goes right forever. It just says longer. Longer could be 1,000,000, right? So it's infinity. And how do we do infinity? We just put in like 7 or 8 nines. So when I do the, what's it called? The normal CDF, we're going to go lower, upper, mu, and sigma if you have the newer kind. So the lower is going to be the left. It's going to be the 20. The upper is the 9s forever. So by lower and upper, they mean left and right. And this, the mu is 16. The standard is 5. So you would put that into your calculator, and the numbers would come out. Is that making sense for everybody, how you do this one? It's all about the left edge and the right edge, what they call lower and upper, or left and right. It's left and right of the chunk of shading. So you got to get that picture. Don't skip that picture. You got to draw that picture because you have to see the left edge and the right edge, the left edge right here, and the right edge is like forever to the right of that chunk of shading, because they're going to do all kinds of tricky things. Instead of just saying longer, they're going to say, you might be thinking, oh, I know this. Well, they're going to get more tricky. They're going to say shorter, between, greater, less. They're going to mix it all around. You're going to have to see the picture. So left edge, right edge is lower and upper. Any other questions on this part? We still got to do part C. Is this part working for everybody? All right, let's go up and do part C. Part C has some trickery to it. All right, so for part C, let me get rid of, Let me get rid of all the scribbling so we have some room to do part C here. All right. So for part C, it says, find the minimum number for the upper quarter of the time to pass the kidney stone. Minimum number for the upper quarter. Okay. Yes, Juan's question is a good one. If it asks for shorter, you would put in negative with a bunch of nines for the lower. That's right. Good job. Good thinking, Juan. We'll get to one of those in a minute, but well done. Exactly right. You've got the idea. All right. So yeah, now this part C is a little more tricky. Let me help you with this. Let's take a close look at it. So really important that you have a picture. It's going to be a little different picture. It's another bell curve, and you're still going to put the 14 right in the middle. But now, watch this. If you're doing yours, dial in with this. This is important to see. They're going to have all different kinds. So on this one, notice what it says: upper quarter. Upper quarter. What does that mean, guys? Upper quarter. If I said, hey, the upper quarter of our class, they're all going to get A's. I hope so. I hope that's the case. The upper quarter of our class is all going to get A's. What does that mean? What percentage is a quarter? If I said a quarter of the people in our class are going to get an A, what percentage is a quarter?
25.
Exactly. Quarter is 25%, right? So they're saying the upper 25%. They're saying the top 25%, aren't they? So if I said the upper quarter of our class is going to get A's, I would be saying the top 25% of our class is all going to get A's. That's probably, hopefully, about true. So does that make sense? So therefore, they want me to go to this graph, this kidney stone graph, and they want me to show the upper 25%. Well, how are we going to do that? What percentage is this right here? I just shaded part of it. What percentage is that?
50.
Yeah, that's got to be 50% because that's half of the whole thing, right? So that's too much. We don't want that much. Well, so what do we want? Well, about half of that. Maybe about right here, huh? Isn't that I mean, it doesn't have to look perfect. I just want you to generally have an idea. That's the upper 25%, about, right? That looks sort of right. You agree with me? Upper quarter, upper 25%. Everybody seeing that? Okay, now how am I going to get it on my calculator? And they want me to find the minimum number. In other words, they want me to find this number right there. They want me to find what number of days to pass a kidney stone puts you in the upper 25%, which none of us want to be in. From what I've heard, kidney stones are terrible. And so if you're a person that has, it takes a long time to pass them, that's rough. And so how many days would that be? Like if you're like 20 days or more, does that put you in the upper 25%? Or is it like 30 days or more? You know, where begins, or maybe it's only 18, you know, where begins the upper 25%? That's the question, right? That'd be like me asking, hey, the top 25% of you guys got what score on the exam? What was, you know, was it like 88% or better on the exam? That was the top 25% of everybody? I don't know, I'm just guessing, but you get the idea, right? We're trying to find how many days does it, you know, for the kidney stone passing, puts you in the upper 25%, right? Find the minimum number of the time to pass a kidney stone that puts you in the upper 25%. Well, how in the world do we find that? Well, we use the calculator. The calculator knows all about this normal curve. It's got all the values inside of it. So we let the calculator do the work. Let's look down at the notes that I provided for you. Notice on this one here, let's go down here again. notice it's saying, let me erase some of this stuff here. Notice it says, when they ask for a percent, when they ask for a percent, when they give you a percent. See the difference? The first two are ask and ask. The third one is give you a percent already. And then you use a different thing, inverse norm, instead of normal CDF. Which one do we have? Which one are they, on part C here, are they asking us for a percentage or giving us a percentage?
Giving.
Yeah, they told us upper quarter. That's as good as telling us upper 25%, right? So they are giving us that percent, aren't they? They're giving us that upper 25%. They're just handing it to us. So that means, coming back down to the notes here, today's notes, we are going to, when they give you a percentage already, here's what we're going to use, inverse norm. Area left, mean, and standard. Let's do it. So that's what we're going to do. So we're going to say, okay, inverse norm, area left, mean, and standard. And so what do we mean area left? Sorry, I didn't write that too well. Area, I'll say to the left. It means area to the left. So what are we talking about? Well, they mean if you go to, we're trying to find this spot right here, right? This is what we're trying to find. How many days to pass your kidney? So it's got to be more than 14, right? If you're 14, you're average. We're talking about the top 25%, something none of us wants to be in, the top 25% of how long our kidney stones last. But what number of days would it require to put you in the top 25%? Well, they say your calculator will tell you, go to inverse norm, but you've got to start with area to the left. So how much is this is area? Please mute your noise. I'm hearing a little bit of stuff there. So what is the area to the left? What do you think, guys? Area to the left there.
Is it 75%?
Exactly. Beautiful. It's got to be 75% because 25% is to the right, huh? See how it says upper 25? So 25% is to the right. So that leaves 75% to the left, doesn't it? Everybody see how we got that? We just take, whoop, sorry, I'm making the thing jump all over the place. We just take 100% minus 25%, and you get 75%, of course, huh? Right? There's, because there's 25% above, so there's 75% below. So this is gonna, now you gotta make it a decimal. So it's gotta be 0.75, and you know the mean, for my mean anyway, the mean is 14 and the standard deviation is 6. So there we go. Just type that in. Inverse norm, 0.75, comma 14 says, I'll do mine, and then I'll do it on the main screen so you can all see it. Inverse norm is in the same menu. It's just one below the normal CDF. And I'm getting an answer that is 18.0469. 18.0469. That's the number, that's right here. That's the number right there. Meaning if you're 18 days or more, if it takes you 18 days or longer to pass your kidney stone, you're in the upper 25%. An upper group that none of us want to be in. So, so let me show you what it looks like with the newer calculator now. So I don't even remember. Go to sharing my screen again. So I'm going to go here, turn it on, and go to the, oh, here, let me clear this. Okay, so here, let me go back where I was at. Okay, so you go to second vars again, go into the menu, go down twice to inverse norm, hit enter. Okay, so it says area, mu. Okay, so the area means area to the left. Area to the left. So that's going to be, can't get to the decimal here, point. Here we go, 0.75. And mine was what, 14? 14. And the standard was 6, right? Yeah, 6. And then just hit enter a bunch. Area, mu, and sigma. There we go. There's that answer that I told you I got with my handheld calculator. Okay, so I'm going to go back to my iPad and write that down. You saw it. You saw it here first. All right. Okay, back to the iPad. So the way it shows it, it says area, mu, and sigma.
I have the new calculator and it's also asking me left, right, or middle.
Oh, that's nice.
Or
Okay.
it's asking me left, center, right.
Yeah, just one second. So area to the left, so that's where I put in the 0.75, the 14, and the 6. So yeah, so tell me, what does your calculator say?
So it has everything that you had right there. And then on the bottom of the standard deviation, it has tail. And it asks me to pick an option, left, center, or right.
Wait, are you sure you're in the right thing?
Inverse norm, yeah. So I want six. Okay, let me clear out.
Huh.
So I want
So for inverse norm,
second verse, inverse norm. That's the third option, right?
right, third option, right.
Yeah, and it's still giving me that.
And it gives you, you're saying it gives you area?
Yes, it gives you
This,
the area.
this,
Yeah,
and
it gives
what-
me all those options. And then the fourth option will be tail. And it gives me 3 options to pick left, center, or right.
Oh, and then left,
Center.
center, or right, like that?
Yes.
Oh, okay, yeah, no, that's a really nice calculator. So basically, it's letting you tell it whether you'd like the area. It's saying this area you gave us right here, this 0.75, is that to the left of your spot, right? Because here's our spot right here.
Yes.
And you're able to tell it left, center, or right. That's nice. Those are even easier to use. So you would just choose left
Okay.
and hit enter.
Okay.
And tell me what, and what that also means is you could have just directly used the 25% and just said right, because to the right was 25%. That would give you the same answer. You could have done right 25% or left 75. Either way, yours is nicer. You don't have to always calculate to the left like we do with the cheaper.
Okay.
Yours allows you all kinds of flexibility like that. Nice. Good. Other questions on this one? Are we good on this one? That's the end of this problem.